Hey guys, it's Miss Casey with the STEM Lab at Bio Academy, and today we're going to talk about another cool event that happens with a lot of weather that we have. So today we are going to talk about lightning. So it's one of my favorite things to watch in storms. It is a little bit scary, but it has a really neat effect in the sky, and it's a lot of fun to watch sometimes. So today we're going to figure out how it's made. I want to read you one of my favorite books from when I was a little girl. It's by Patricia Polacco, and it's called Thunder Cake. I remember my mom reading this book to me when it was thundering and lightning a lot. So I want to read this book to you for our fiction book today as we talk about lightning, and so thunder and lightning going together, okay? So this is Thunder Cake by Patricia Polacco. On the sultry summer days at my grandma's farm in Michigan, their air gets damp and heavy. Storm clouds drift low over the fields. Birds fly close to the ground. The clouds glow for an instant with a sharp, crackling light, and then a roaring, low, tumbling sound of thunder makes the windows shudder in their panes. The sounds used to scare me when I was little. I loved to go to Grandma's house. Babushka, I used to call my grandma. She had come from Russia years before. But I feared Michigan's summer storms. I feared the sound of thunder more than anything. I always hid under the bed when the storm moved near the farmhouse. This is the story of how my grandma, my babushka, helped me overcome my fear of thunderstorms. Grandma looked at the horizon, drew a deep breath, and then said, "This is thunder cake baking weather. All right, looks like a storm is coming to me." "Child, you come out from under that bed. It's only thunder you're hearing," my grandma said. The air was hot, heavy, and damp. A loud clap of thunder shook the house, rattled the windows, and made me grab her close. "Steady, child," she cooed. "Unless you let go of me, we won't be able to make a thunder cake today." "Thunder cake?" I stammered as I hugged her even closer. "Don't pay attention to that old thunder except to see how close the storm is getting. When you see the lightning, start counting real slow. When you hear the thunder, stop counting. That number is how many miles away the storm is. Understand?" She asked. "We need to know how far away the storm is so we have time to make the cake and get it into the oven before the storm comes, or it won't be a real thunder cake." Her eyes surveyed the black clouds away off in the distance. Then she strode into the kitchen. Her worn hands pulled a thick book from the shelf above the wood stove. "Let's find that recipe, child," she crowed as she lovingly fingered the grease-stained pages to a creased spot. "Here it is, thunder cake." She carefully pinned the ingredients on a piece of notebook paper. "Now let's gather all the things that we need," she exclaimed as she scurried toward the back door. We were by the barn door when a huge bolt of lightning flashed. I started counting like Grandma told me to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then the thunder roared. 10 miles, it's 10 miles away," Grandma said as she looked at the sky. "About an hour away, I'd say. You'll have to hurry, child." "Gather them eggs careful like," she said. "Eggs for mean old Nellie Pick Hen." I was scared. I knew she would try to peck me. "I'm here. She won't hurt you. Just get them eggs," Grandma said softly. The lightning flashed again. 1, 2, 3, 4, 5, 6, 7, 8, 9. I counted. 9 miles, Grandma reminded me. Milk was next. Milk from old Kit Cow. As Grandma milked her, Kit Cow turned and looked mean right at me. I was scared. She looked so big. Zip went the lightning. 1, 2, 3, 4, 5, 6, 7, 8. I counted. Baroom went the thunder. 8 miles, child, Grandma croaked. Now we have to get chocolate and sugar and flour from the dry shed. I was scared as we walked down the path from the farmhouse through tangleweed woods to the dry shed. Suddenly, the lightning slit the sky. 1, 2, 3, 4, 5, 6, 7, I counted. Boom, ba-boom! Crashed the thunder. It scared me a lot, but I kept walking with Grandma. Another jagged edge of lightning flashed as I crept into the dry shed. 1, 2, 3, 4, 5, 6, I counted. Crackle, crackle, boom, kaboom! The thunder bellowed. It was dark and I was scared. I'm here, child, Grandma said softly from the doorway. Hurry now. We haven't got much time. We've got everything but the secret ingredient. 3 overripe tomatoes and some strawberries, Grandma whispered as she squinted at the list. I climbed up high on the trellis. The ground looked a long way down. I was scared. I'm here, child, she said. Her voice was steady and soft. You won't fall. I reached 3 luscious tomatoes while she picked strawberries. Lightning again. 1, 2, 3, 4, 5, I counted. Kabang! Baroom! The thunder growled. We hurried back to the house in the warm kitchen and we measured the ingredients. I poured them into the mixing bowl while Grandma mixed. I churned butter for the frosting and melted chocolate. Finally, we poured the batter into the cake pans and put them into the oven together. Lightning lit the kitchen. I only counted to 3 and the thunder rumbled and crashed 3 miles away, Grandma said, and the cake is in the oven. We made it. We'll have a real thunder cake. As we waited for the cake, Grandma looked out the window for a long time. Why aren't you afraid of thunder? You're too brave, she said as she looked right at me. I'm not brave, Grandma, I said. I was under the bed, remember? But you got out from under it, she answered, and you got eggs from mean old Nellie Pick Hen, and you got milk from old Kit Cow. You went through Tangleweed Woods to the dry shed. You climbed the trellis in the barnyard. From where I sit, only a very brave person could have done all them things. I thought and thought as the storm rumbled closer. She was right. I was brave. Brave people can't be afraid of a sound, child, she said as we spread out the tablecloth and set the table. When we were done, we hurried into the kitchen to take the cake out of the oven. After the cake had cooled, we frosted it. Just then, the lightning flashed, and this time it lit the whole sky. Even before the last flash had faded, the thunder rolled, boomed, crashed, barang-o-broom just above us. The storm was here. Perfect, Grandma cooed, just perfect. She beamed as she added the last strawberry to the glistening chocolate frosting on top of our thunder cake. As rain poured down on our roof, Grandma cut a wedge for each of us. She poured us steaming cups of tea from the samovar. When the thunder roared just above us so hard it shook the windows and rattled the dishes in the cupboards, we just smiled and ate our thunder cake. From that time on, I never feared the voice of thunder again. And so then we have our recipe for our thunder cake, and I'll make sure. A really great nonfiction book about lightning is Lightning by Seymour Simon. Has some really great actual photographs of lightning. I love his photographs because you see a lot of the different colors that we see when we see lightning storms or lightning in the sky. So it's got just some single bolts of lightnings, and then we have, you can see where it's hitting some power lines and things like that. And so then it looks like the lightning's dancing across the sky and the purple tones. So I do love that this book highlights a lot of the different colors that we can see when we see lightning in the sky. So another great nonfiction book for our lightning is one of our science vocabulary readers by Scholastic. And this one is called Lightning. Has great little chapters about what lightning is, what causes it. Let's see, some different facts and different categories of lightning that we have, like the sheet lightning or fork lightning. Safety for lightning, about not touching something that's wet outside, how lightning can cause forest fires and things like that. A bolt of lightning can be 50 miles long, so it's got some great little information. So this is great for our younger readers. So this is one of our favorite things that we had in our electricity unit. We had this cool plasma orb in our dark room that we had in the STEM lab. So I was really excited to get out our plasma orb again because it is a really cool visual of what lightning kind of looks like as it goes through the sky. So our plasma ball works because we have this electrode in the middle and it is surrounded by a tiny layer of glass, and we have our glass ball out here. And then all on the inside is different gases And the electrode produces that negatively charged, gives us a negative charge. We have those negative electrons coming off. And so when those negative electrons hit that positively charged ions and stuff like inside the orb, that's how we get our cool little electric tendrils coming around in our little plasma orb. So the light in our orb can appear different colors because of the different types of gases inside our plasma orb. So lightning can appear to be different colors because of the different atmospheric pressure or the atmospheric climate or temperature that it is in the certain areas that you see the lightning strike. If it's open air when the lightning strikes, it can emit like a white light. Or if it's got moisture in the air, you can see more of a red and orangey color with the lightning. So the color of lightning really does kind of depend on where you are, what the temperature in the atmosphere is like where that lightning is striking. So lightning is super hot. When we hear the clap of thunder after we see the lightning, so remember that we see lightning first because lightning travels faster than sound. So that's why we hear the clap of thunder after. So this clap of thunder actually comes from the lightning happening. So lightning is really hot, and so when the lightning strikes, the air expands, because when air is hot, it starts to expand. So when the lightning pops, you hear the air starts to expand because of the heat, and when that air gets cold again, it contracts. So when it goes from expanding to contracting super fast, that's when we get the loud clap, so we get the clap of thunder. Okay, so to understand a little bit more, I want you to think about a magnet. So you know when we take two magnets and we push them together, sometimes it's like they resist each other because you have the same ends, like you're pushing the positive ends together, okay? So if they're the same, they're going to push away from each other, and if they're the opposite, they're going to attract. So that's why we have to have like the positive and negative to make sure they're in line in our circuits. Kind of the same thing in our clouds, where the magnets, the positive and negative, attract each other. So think about in our big fluffy storm cloud, that cumulonimbus cloud, the positive currents are on the top, the negatives on the bottom. So they're attracting to each other. When they're attracting, they snap and then they send those charges back. So when the negative charges on the bottom are resisting the negative charges on Earth, and that's where we get our lightning strike. So I just want to give you a visual one more time of how that lightning actually happens. So again, we have to have those clouds, and we start with one of those fair weather, big, pretty, cartoon, fluffy clouds, the cumulus clouds. And so when it starts to turn dark and they get really tall, you know it's going to turn into a storm cloud, which would be that cumulonimbus cloud, okay? So we'll have that cumulonimbus cloud, and in that cloud, we see the positive and negative charges start to concentrate. So we're going to see those positive charges start to concentrate at the top of the cloud, and we'll see those negative charges start to concentrate at the bottom of the cloud. So remember how we talked about those magnets, that the like ends of the magnets really repel each other, and the opposite ends of the magnets are attracted to each other. So that's just like our positive concentration of charges and our negative concentration of charges. So we have those negative concentration of charges right here at the bottom of the cloud. They are going to push away from the ones that are on the surface of the Earth. So the negative concentration of charges at the bottom of the cloud are pushing really hard away from the negative concentration of charges that are on the Earth's surface. So they push away and they push away, so you're only left with positive charges down here on the Earth. So when it's more positive than it is negative down here on Earth, what happens after that? So our positive and negative are attracted to each other, and that's when we get that big crack of lightning. When we were doing our electricity unit, we talked a lot about static electricity. So remember when we did the fork and we rubbed it in our hair, we put it over the pie plate with the salt in it, we made the salt or the pepper dance. Or when we took our PVC pipe and we rubbed it with our wool yarn and we made the balloon float or the plastic bag move. And I think everybody's favorite was when we took the balloon and we rubbed it in our hair until we made our hair stand on end, and we would get that static electricity in our hair. And we gave an example of static electricity being a lightning strike, because when we get that static electricity is when we pick up all those free electrons, and that's how that charge comes. So that's when we get that lightning strike, and that is our static electricity. So that static electricity that we were talking about, sometimes when you touch that Walmart buggy and it'll shock you, it's nothing but a little pinch and it's fine. But we have to remember that a lightning bolt is a lot stronger than the static electricity from the grocery cart. So when we get that loud crack of lightning, that's when we have that electrical current. Guys, I want you to think about our last unit when we talked about electricity. So when we were talking about creating a circuit, we have a power source, and then we would have something to have our circuit carry our power source to charge what we wanted to work or move or something like that. Okay, so we have to have our power source. So we, like if we have a battery, and a battery has a positive and a negative end, and then we will have our conductors. Okay, so we have our conductor, which would be our copper wire with our insulator that is wrapped around it, so that protects us from getting shocked. Okay, so when we talked about those circuits, again, we had to have our power source, and then we would connect our power source using our wires. Okay, so we made these simple circuits. So we would light the light bulb. Right, and remember, you can do this with or without a little fancy light bulb holder. If you just have something like aluminum foil or a pipe cleaner, you can take your battery. So remember, you have to have a closed circuit for it to power the source that you want to send the power to. So you'll have something to connect to your positive side and your negative side, and you'll go to your resistor, okay? So like your light bulb, so that's what's gonna catch that power source, okay? So, and if you have the closed circuit, you will be able to power whatever it is that you're trying to power. So I was trying to pick it up. All right, so if we close our circuit, we have this. So you may think, why is Miss Casey trying to light a light bulb when she's teaching us about lightning? So the electric current is the flow of electricity between two or more charged objects. So in this case, it's the cumulonimbus clouds and Earth. So in our fiction book and our nonfiction book, we talked about the speed of lightning. So the speed of light is a lot faster than the speed of sound. So even though these facts are a little bit different from what Thundercake tells us, so we do know that because the speed of sound is a little bit slower, so it takes about 5 seconds for sound to travel a mile. So if we see that strike of lightning, we can start counting. And if we can get to 5 and then we hear the thunder, we know that the storm is about a mile away. So we can totally see where Grandma gets the idea about for every second after the lightning strikes for you to hear the thunder, that the storm is about a mile away. So try as I may, I tried really, really hard to find a really cool experiment about lightning. So without creating a Tesla or cracking open one of our plasma orbs or trying to shock myself, the best I can do for your STEM challenge today is to create your own thunder cake. So this would be a cool memory for you to make with your family during our time apart. So I want you to make your own thunder cake with your family. You can use the recipe that I'm going to post, or you can find your own recipe. And I want you to work really hard using your measuring cups and following step-by-step procedures to make that cake the best you can. So this is your STEM challenge for this week, is to create that thunder cake.